Hey James, thank you so much. I'm really super happy to be here. My name is Matias Quaranta. I work on the Cosmos DB Azure Cosmos DB team as a software engineer. And we'll be talking about, as James said, about building this scalable event-driven application using Cosmos DB and Azure Functions. We recently did a release of the new Azure Function extension, what we call the V4 or 4.x version. And I wanted to first go through the most important highlights that this new version comes with. And then we'll be delving into kind of popping the hood out of the extension to learn how the trigger or event-driven hook that we have works, and then building a dashboard on top of it to learn about monitoring. And finally, I have kind of like a bonus or gift for everyone here that is attending. So hopefully we'll get this through. So let's start with the highlights. Most important things that you will look or you will find in the new version. If you're currently using the extension, the V3 extension, you should be looking into upgrading. If you haven't built any Cosmos DB event-driven applications using Azure Functions, this is the new version that you should be using. We support managed identities out of the box, which means that you don't need to deal with connection strings anymore. You don't have to build weird Azure Key Vault wirings. You can just use the managed identity that is on the function app and assign RBAC permissions to that identity on Cosmos DB, and that will just work. We added and extended the login that we produce on the extension, so for you to debug and even check performance on different scenarios. We'll be taking a look at that in a minute. We added a custom serialization engine for JSON. So we know that Cosmos DB stores documents as JSON. So there is a process, and we'll see it in a bit, where that raw JSON travels into your Azure function code. That goes through a JSON deserialization process. Or if you're saving data, that goes through a serialization process. We enable on .NET, as a developer, you can customize completely the JSON serialization engine. You can replace it with system.json, Newtons of JSON, whatever JSON engine that you want. Any custom settings, you can use it there, and it will apply to all the extension interactions. We added support as one of other Azure Function services, Azure services, added support for retry policies. That means that you can set up a specific amount of fixed retries or even exponential retries in the case that the code that you're building in your Azure function fails in a transient way or in an unexpected way. We'll be also taking a look at that. And finally, you have access to the latest and more recent Azure Cosmos DB.NET SDK when you're using the latest extension. Now, those are the highlights. Those are the main reasons that you want to use this new extension. And we know that Azure Functions extensions allow for three main things. We have the input bindings, which allow you to read data. You have the output bindings, which allow you to write data. And we have the triggers. I want to focus on the trigger because it's probably one of the most interesting parts, and that will allow you to build these event-driven applications. So let's start with how does the event flow work. So you have a Cosmos DB account, you went into the portal, you created your account, you selected your regions that you want your data to be replicated to, and you start by creating an Azure function. And that's when we are going to jump into the code. You'll start, obviously, by creating your Azure Functions project. You want to add the Azure Cosmos DB extension, and you want to use any of the most recent 4.x versions to use the latest extension version. And you will probably start by writing something like this. You will have your function name, and then this is the syntax for the trigger. So you will start with decorating it as a Cosmos DB trigger, and you want to first define three key things, which is a database name, which is a container name, and which is the connection. The connection will take care of, obviously, connecting to your Cosmos DB account. You can use connection strings, but you could also leverage managed identities. And then what are these databases and container names? Well, but when going back to the slides, we have the concept of a container in Cosmos DB. The container holds all your documents, all your data that you are saving and storing in Cosmos DB. This container, when you create it, you define what we call a partition key definition. In this case, in the example that we are seeing on the screen, we have defined that for this container, the city, let's say that we are storing telemetry coming from different regions in the world or different cities. I'm storing data, and this data, this piece of information, contains one property called the city. This is a concept of the logical partition key. Each document that you're saving will contain a city value. Within Cosmos DB, within the container, we have also the concept of physical partition key, and that is how the data that you are storing gets stored physically in partitions. So what we'll see is, in this example, we are seeing a container that has 4 physical partitions tracking ranges of these logical partition keys. So the first physical partition will hold documents that for the city property contains values that range from A to H, and the second physical partition contains values from H to L, the third one to L to R, from L to R, and then so on and so forth. So the number of physical partitions is driven by the volume of data that you are storing. So as your container grows, these more partitions will be provisioned for you automatically and transparently. You don't need to do anything, and the container will scale dynamically for you. So if we are building a project that wants to react, a function app that wants to react to any new document or event that happens on this particular monitor container, I will grab the database name and container name, and that's what I'm going to save or write into these 2 pieces of information. And what I'm telling is I want to trigger this Azure function whenever there are any new changes on this particular container in this database in this Cosmos DB account. Now, going back to the slides, we have this container. Let's say that it has, for the sake of example, 4 physical partitions. Now, there is this concept of the change feed processor. What is happening underneath, under this function or this simplicity that is just writing Cosmos DB trigger, is that we are running the Azure Cosmos DB.NET SDK. The .NET SDK has this concept of the change feed processor, which is a construct that what it will do is it will hook into the container that you want to listen to, and then it will start to read, and we'll see in a second how it does it, but it will start to read the changes from a feature or an endpoint called the change feed. This change feed endpoint is available on all in all containers in Cosmos DB. You don't need to enable anything extra. So the change feed processor will hook into this change feed on this container, and it will use something that we call the list container. The list container is also present here in the configuration, and you need to define this second container where we'll store something we call the list documents. These list documents, what they track is what's the last point in time that your function has successfully processed the events that are happening in this monitor container per physical partition. So in a container that has, in this case, 4 physical partitions, this list container will have 4 documents, each one tracking the progress of each individual of these 4 physical partitions. The name of the list container is completely up to you. I mean, we have a default value of Leases, but you can call it whatever you want. Another interesting setting that we have on the trigger extension is the preferred locations. When you create a Cosmos DB account, you can define, to have your account in multiple regions. That means that your data, including the change feed events, is also replicated across all your regions. So you could deploy your function app in multiple regions or in just one and define which is the preferred locations you want to read the data from. Ideally, you want to read local data, which means that if I'm, for example, deploying my function app in West US, I want to make sure that my preferred location is in West US. And one very cool thing that function has is that the actual values of this property, I don't need to hard code them. I could use a syntax like this, which will say, okay, here is going to have a value, but I'm going to define the value on the function app configuration itself. So the code will grab this value on runtime. This enables me to have multiple versions of my trigger or deployed in multiple regions, and each one might have a different region value. And that applies to any parameter, right? I can even have multiple versions of the same trigger pointing to different monitor containers if I wanted to. And I can make this without touching the source code. I can deploy the same bits across multiple regions and have different configurations and apply those configurations on runtime. Then I have the max item frame invocation. What it does is it defines what's the max batch size that I want these events to be triggered on my function app. As you are probably seeing here, the trigger input, what is given to your function code, is a list of changes that happen on your monitor container. The size of these events can vary. So depending on what you're doing in your function app, this size, you can increase it or decrease it depending on your own workload, but you can customize that value using this optional property. And finally, we have this called the list container prefix. What this does is it gives a unique identifier to these list documents. I could reuse the same list container for cost purposes for many function app triggers. Ideally, what I want to do is I want to have a unique identifier for this particular function app. This also can be a setting that can vary dynamically, but I want to have a unique identifier to define this set of leases that is meant to track the changes that are happening on this particular container. So up until this point, what we have is I have written a Cosmos DB trigger. I'm telling it, hey, I want to hook into the changes that are happening into this container. I'm going to track changes in this list container. I want to read the changes from this region. And I want to store all my leases with this unique identifier. All of these changes, all of these attributes are actually optional. The most critical ones are just these three. The rest have default values, but I'm trying to showcase like a more advanced configuration. Once I deploy this to function apps, what is going to happen is my function app will wake up and trigger whenever there is anything happening on the monitor container. But let's actually take a look at the entire process. So once I deploy my function app, let's assume that I'm deploying a single instance. So I toss it over to Azure, it's running. The first thing that will happen is the Change Feed processor will acquire these leases. So let's assume that we have these 4 leases. It will acquire each of the leases. So that instance will acquire these leases and will start to process them. One of the things that I was mentioning on the highlights was that we added more logging. So if you have your function app hooked into application insights, one thing that you can do is you can even check the different traces with different levels. And one of the things that you will see is whenever an instance, one of your function app instances, starts to process one of the leases. So you can actually track when a particular machine starts to process a particular lease. In this case, you will see these traces. We have different levels of traces in our documentation. We have error traces, warning traces, information traces, debug traces, and we explain all the different levels, which critical pieces of information they can give you for debugging purposes, for investigating performance, or only for tracking critical issues that are happening while your function is running. For this case, for this talk, what I'm doing is I'm enabling them all, so we can see all the potential logs that we are producing. In this case, this is the first one. So the Change Feed processor is running in your function app. It sees all these leases, it starts to acquire the leases. Once the lease is acquired, what the processor will do is start to read the change feed for each of the acquired partitions for each of the leases that it has acquired. This is a request that is done on to your Cosmos DB endpoint, and we will get this list of raw JSON documents. Once we get these changes, we first deserialize these documents. We deserialize this raw JSON, and here is the part where we look into how we go from raw JSON into whatever POCO or type that you will define here. You will see that I created this. I have this device telemetry. I have a function app that is receiving events that are telemetry from different devices. And I have this C# class here that has just 2 properties. Now this, I mentioned at the beginning that we enable custom serialization and custom serialization engines. So what you can do is you can go into your startup.cs file in your function project, and you can use dependency injection, and we enable this new interface called iCosmos DB Serializer Factory. what you can do is you can define a custom implementation that will give the extension and custom implementation of the Cosmos Serializer interface. The Cosmos Serializer is the API that the Azure Cosmos DB.NET SDK will use to serialize and deserialize all raw JSON. This API is really simple. It just has two methods, which is from stream, which is basically the part when we receive the raw JSON and we convert that into an instance of your class, and then the opposite, which is we grab an instance of your class and we convert it to a stream. You can use whatever serializer you want, whatever technology. In this case, in this example, I'm just using a custom system type JSON serializer that has these particular custom options using property name cases as insensitive, but you can actually do whatever you want as long as you implement the Cosmos Serializer interface. And this will inject your custom serializer into these interactions. So once once we send this, we receive this raw JSON on the Change Feed processor that is running underneath your function app, we'll use your custom serializer and we'll deserialize. And when that happens, we'll send those changes to your function app. And that is also something that you can see on your attached application insights. For example, I can see that these are logs that are showing that events were delivered to list 5. And we can also include the actual diagnostics. The diagnostics are the traces that the SDK emits that show, for example, let's look at the custom dimensions. They show the actual network requests and how long those network requests took to actually obtain those events and then pass them over to the serialization process and into your function app. So if you are looking into troubleshooting network latency or performance, you want to look at, okay, is there anything happening on the networking layer that is making my delivery of changes slower? You can take a look at how many milliseconds the entire network process took in order for your function app to receive these changes. Now, once we deserialize these changes, we send it to your function app, and that's when you do whatever you want. Like in this case, this function app, what it's doing is just also using an output binding, grabbing all these events, grouping them by device, and applying a summarization. This is very simple, but for the case of this example, what it's showing is how you can grab some trigger events, process them, and then use an output binding that is also using the same extension to save a summary of those events into another container. Now, whatever code you're writing here, it could fail. I mean, there could be transient issues. You could even have a bug, right? Or something might go wrong. It would be ideal for your function to be resilient to these potential transient issues. So one way to do that is we have these decorators that are supported for multiple Azure services, including Cosmos DB, that can let you define retry polysize. So this one, for example, is saying I want to retry up to 3 times with 5 seconds in between for a fixed amount of time. But there are others. There is one that is an exponential backoff. So depending on what you are doing, you can define your custom retry polysize. And in the case of an exception, what you will see in your logs is something like this. So you will get exceptions in your application insights logs, and you can see these exceptions that are happening. And at some point, you can even see that the function app execution in this case failed after 3 retries. So what happens is there is an exception. The exception gets logged. The function app will take the same batch of changes and re-trigger your Azure function with the exact same batch of changes, hoping that was a transient issue. If the issue persists, well, in this case, it will retry again and again and again until all retries are exhausted. But this gives you at least a guard with transient failures. And everything here is also logged in your application insights monitoring. Okay, next one is, assuming that the whole process succeeds and everything is great, what we do is we checkpoint. So we save, okay, up until this particular point, all the changes in this particular partition have been successfully processed. Let's move let's move to the next one. So we repeat the process of going back to reading the changes, deserializing, sending them, checkpoint, reading, deserializing, checkpoint, and that's how the whole process works. Now, this lives inside an instance, right? And we have these multiple leases. In this case, there are 4. There could be way more. Now, when you create a function app, you can define different types of plans. One of them could be the consumption plan that dynamically scales. You could even go and define manual scaling rules and mechanisms, or even control manually. Okay, I want to have only 3 instances of this particular function app. What will happen is that dynamically, the function app extension, it will distribute the leases equally to an equal distribution algorithm across all your existing function apps instances. So in this case, if I scale either dynamically or manually my function app into 2 instances, it will grab these 4 leases and it will split them into these 2 instances. And this happens dynamically either up or down. If I go back to having 1 instance, then now this instance is owning these 4 leases and we'll start to process them all. Or if I increase, it goes back to dynamically distributing them. Now, this whole process of delivering events is based on this feature that I mentioned earlier called the change feed. You can see the change feed as a timeline. So at some point, your trigger has a cursor, which is defined by these leases that are maintaining the checkpoints. But your container, the container that you're monitoring, might be progressing and having more events. So the biggest question that some of I've seen most commonly asked is, but how far behind is my trigger? Like, am I processing real time? Do I have any delays? So wouldn't it be cool if you could have a measure of how far behind your trigger is? So that's when, as part of this talk, I wanted to showcase how you can actually build this. So you can take a timer trigger, define this timer trigger to fire as frequently as you want, and then use something that I will show that is part of the Cosmos DB SDK called the Change Feed Estimator. The Change Feed Estimator will look at these leases and calculate how far behind each of the leases is from the actual live container. And then we can grab this estimation and push it into application insights to eventually create something like an Azure dashboard. So going back to the code, this is basically what you could do. So you can create a timer trigger. In this case, I'm defining it every 30 seconds. I'm using the Cosmos DB binding, so I'm using the same authentication mechanism. But in this case, I'm pulling the actual SDK client. So as an advanced scenario, I can actually access the .NET SDK client, and I can call this estimator. The change feed estimator, it takes 3 pieces of information. It takes the monitor container, which is the container that I want to listen for changes on, which is basically this one here. It takes the list container, which is the one that is storing the leases, and it takes the identifier of the change feed leases that I was using. So if we look at the previous trigger, this maps to the list container prefix. So I can create this change feed estimator. I created as we are using a iterator pattern, and then we iterate on this estimator, and each item on this estimator will give us for each list which is the estimator in terms of the estimated lag between the current point that we have and the live partition on the actual container. So we can produce this sort of metric, which in application insights looks like this. So it's you can tell for each of the leases. In this case, I have a container that has 9 partitions. For each of the leases, which is the estimated lag, and who is the instance that is owning it. Now, why would you want to know who is the instance that is owning it? Because you can build something like this. So you can grab this application instance data and build some queries that I will share with you in a minute. And you can produce a dashboard that can show you, for example, for each of the instances, in this case, my function app has 3 instances, what is the lag that each machine, each instance is experiencing for this particular monitor container. Or I can go and say, and apply the same thing for each of the leases. I can identify, hey, is there a particular lease that has more lag than the rest? And the key here is identifying patterns where the lag is increasing. Like you will never be real time. You will always be lagging behind a bit. But the part that you want to use these dashboards and these metrics for is identifying patterns where the lag might be increasing for a particular machine or a particular set of leases, which would point for the case of the leases, any hot partitions where you are maybe, instead of distributing your data across the entire container, you are maybe sending too many writes, too many documents to a single subset of partitions, and that is causing your processing to lag behind. Or maybe there is something in particular to one of the instances that is having issues. Maybe it's you want to investigate maybe CPU or networking constraints, and you want to take a look at, okay, this particular machine is undergoing some particular problem. So maybe I want to investigate, and maybe I want to restart this machine. Maybe I want to take a look at what is going on. And finally, one other thing that I can do with this actual set of data is look at the distribution. In this case, I have 9 leases. I can actually see that each of my 3 instances is owning exactly 3 leases. So as my instances grow and shrink, I can see what's the dynamic distribution of the leases across the existing running machines. So just to wrap everything up, I want to share with you the entirety of my talk, including all the source code. And even the Azure dashboard is available on GitHub right now. You can go to this repo, you can clone this repo, you can reference this repo. It contains not only the source code, a README to guide you on how to actually duplicate exactly what I did today. And one cool thing about Azure dashboards is that you can actually export them. So it contains a JSON file. This JSON file is the actual same dashboard, the same queries that I was just showing you. The only thing that you need to do is you need to make sure that you are adjusting based on the documentation the actual resource path for your application insights that is stored in these metrics. But once you do that, you can just grab that JSON and create automatically your own dashboard to track the progress of your function apps. I hope that this content was useful for you, and you can take this monitoring to the next level and create useful dashboards on your Azure Function apps.
I love getting great examples where we can take it and run with it and edit it ourselves and figure it out. It's a great way to get started, learn the functionality, get to play around with it and figure out how it works. Thanks, Matthias.
My pleasure.
All right, so we have a couple questions for you. Can we start with, here's a quick one. Is the Cosmos DB example available in all language workers?
Right, so one cool thing is that how Azure Function works is we build the C# extension. But on top of that, we have the Azure Function has a concept of bundles. So this same C# extension that is running is available in other languages on top, using the bundles. The bundles are also versioned with the same values. I think it's the 4.x bundles will contain the 4.x extension of the Cosmos DB extension.
Awesome. Seems like people are already forking your examples.
Awesome. Hopefully it's useful.
Yeah. Can we talk about how partitions are set up in Cosmos real quick? I think we had a couple questions. They got answered in chat, I think, but it would be good to just cover it real quick here.
Sure. So partitioning in Cosmos DB is automatic. So what you do is you create the container, you define your partition key. This is just an example trying to explain how a potential distribution could be. But what happens under the covers is when you store a document, the service grabs that partition key value, in this case, the city, and applies a hash algorithm. So your data will be evenly distributed across all physical partitions, assuming that you are using a distribution of frugal values of your partition keys. It's not actually, or potentially not using actual like A to H, like it's ordering letters. The letters were just a representation of a potential distribution algorithm, but the service is a bit way more smarter, using a different hashing algorithm to make sure that the values are evenly distributed across all physical partitions.
Awesome. Thanks. All right. Well, those were the questions that we had. Thank you so much for joining us today.
My pleasure.
Have a great rest of your afternoon.
You too.